Hello. Thank you everyone for joining us this evening. My name is Julian Thibault. I'm the president of the American Research Center in Egypt, Detroit, and this is our first lecture event. So thank you so much for joining us. Today we're going to be discussing, listening to presentations and discussing research being carried out by conservationists by conservators in museums in our area. So I think it's gonna be a really great discussion. And I also have the privilege of introducing our first speaker for the evening. Also, if you have questions throughout the presentation, please go ahead and put them in the Q&A box, and we'll address them after both speakers have finished with their presentations at the end. So we'll be monitoring the Q&A box throughout the conversation, and we'll get to your questions. So our first speaker is Caroline Roberts, who will be discussing re-engaging with Roman Egyptian portraits and panel paintings through technical research at the Kelsey Museum. Caroline Roberts is an archaeological conservator and a graduate of the Winterthur University of Delaware program in art conservation. Carrie's professional background includes postgraduate fellowships at the Kelsey Museum of Archaeology, at the University of Michigan, the J. Paul Getty Museum, and the Metropolitan Museum of Art. Her research interests include the conservation of stone artifacts and architecture in museum and field settings, the characterization of ancient polychromy, and preventative conservation. Carrie's conservation fieldwork experience includes seasons at Haman Kalhuyuk in Turkey, Selinut in Sicily, El Kuru in Sudan, and Abydos in Egypt. She is a professional associate of the American Institute for Conservation. Give it up for Carrie.
Hi, everybody. I'm going to share my screen, hopefully with success. There we go. So thanks, Julian, and thanks everybody for being here. It is such a pleasure to be here virtually with you this evening for this inaugural RC Detroit event. I am really happy to share with you all some of the discoveries that we conservators and collaborative conservation scientists have made while studying Roman Egyptian panels at the Kelsey Museum. This technical research was made possible through collaborations with colleagues at the Detroit Institute of Arts and through student engagement here at U of M. Before I jump in, I wanted to acknowledge that much of our panel paintings research was funded by an NEH Research and Development grant to study color, namely pigments and dyes, on Roman Egyptian material in the Kelsey's collection. The primary goals of this grant have been to gather data on the materials and technology of color on Egyptian artifacts from this later period, and to make technical color research more accessible to smaller institutions like ours. The Kelsey Museum of Archaeology at the University of Michigan houses over 100,000 artifacts from the ancient Mediterranean, Near East, and North Africa. This includes a collection of Roman Egyptian artifacts from the ancient city of Karanis in the Fayum, a site that was excavated by the university in the 1920s and 30s under the auspices of our museum's namesake, Francis Kelsey. The Kelsey is somewhat unique in that it preserves both artifacts, including a wealth of objects from daily life, as well as archival photographs, maps, and field notes from Karanis and other sites, meaning that many of the museum's collections can be linked to a documented archaeological location. Which brings me to the focus of our research, the panel paintings. 3 of these paintings were excavated at Karanis, and like other artifacts discovered there, they were brought to the museum through division or partage agreements made between the university and the government of Egypt, which I should note at the time remained under the influence of colonial authorities. The remaining panels came to the museum through purchases, some by Francis Kelsey himself. Tonight, I'll focus on 3 of the paintings. The first is this portrait of a woman, which was purchased by the museum in 1935. The woman is notable for her Trajanic hairstyle, her abundant jewelry, and the rich purple robe she wears. Her portrait was featured in Ancient Color, an exhibition I co-curated with our museum's education director, Kathy Pierson, back in 2019, and which included a section focused on the scientific study of colorful objects. At the time of this research, we had limited in-house analytical capabilities. So we joined forces with conservation scientist Christina Bisulca at the Detroit Institute of Arts to learn more about how the panel was painted. I began my investigation with multispectral imaging. Multispectral imaging, or MSI, is a photographic technique in which a visible ultraviolet or infrared light source is directed onto an artifact paint surface. Pigments and dyes absorb, reflect, and emit light in characteristic ways that can be captured in an image. So we use this technique both for material identification and as a way to map out the locations of specific colorants on an artifact. In the case of the portrait, MSI revealed something interesting about the woman's purple robe and the purple gem on her pendant. Here's the portrait under visible light, and I'll point out the pendant here, this one here, and you can see her robe, of course. And here's the portrait under ultraviolet light. There are a number of fluorescent materials visible here, including a yellow luminescence in her neck, chin, and background, and a milky blue fluorescence on her face. But what's really of interest here is what's going on in the woman's robe and in the oval gem on her pendant. Both have kind of a faint pink fluorescence that is characteristic of the plant-based red organic pigment rose madder. Visible induced infrared luminescence very clearly shows the use of Egyptian blue in the robe. Here. When we compare the ultraviolet and infrared luminescence images, we can see that the rose madder and Egyptian blue overlap. This suggests that they were mixed together to create purple in the woman's robe. Now, Egyptian blue is notably absent from the gem. There's no luminescence here. And I'll talk more about this in a moment. To help us make more sense of the imaging data, Christina Bisulca, pictured here, traveled from the DIA to the Kelsey with her museum's fiber optic reflectance spectrometer, this instrument. We use this instrument to analyze pigments in different regions of the painting. The fiber optic analysis confirmed what multispectral imaging had suggested, that the purple robe was created using a mixture of rose madder and Egyptian blue. So here's the faint pink for madder, and, oh, sorry, I'm looking down here. And Egyptian blue shows up here in this blue line. It also helped us solve the mystery of the purple gem. The reflectance spectrum for the gem suggests that it contains rose madder, as well as the plant-based blue pigment indigo. So a different blue pigment was mixed with madder in that case. At least two different reds were also used. Red ochre, a naturally occurring iron oxide mineral, was used in the flesh and lips, while cinnabar, the mercuric sulfide pigment used in wall paintings, and that was mined in Roman Spain and Turkey, was used in the gems on the woman's necklace. Using polarized light microscopy, a technique we have in our lab at the Kelsey, and FTIR spectroscopy at the DIA, we were able to examine and analyze tiny paint samples taken from the artifact's surface. Microscopy helped confirm the artist's use of carbon black in the hair, background, and flesh tones, Egyptian blue in the robe, and green earth in the green gems of the necklace. The green earth was of particular interest to me. I've been studying its use in Egyptian painting for years, and it remains unclear whether artists sourced this mineral in Egypt or elsewhere in the Roman Empire. The iron-based green mineral occurs naturally in Egypt's western desert, but it is also abundant in Italy and Cyprus. Finally, Christina confirmed that the binder used in the portrait was beeswax, likely mixed with pigment and applied warm to the surface using a hot metal tool. FTIR also revealed the use of lead white in the figure's skin and in the portrait's background. The Romans manufactured this white pigment using lead sources that were available throughout the ancient Mediterranean, from Spain to southern Greece to Turkey. These are colorants that reflect the considerable range of material goods and pigment technologies that were available within the expansive trade network of the Roman Empire. Also compelling is the fact that the artist who painted this portrait opted to use at least two different blue-red combinations to create purple. Why? Well, Egyptian blue, indigo, and madder all were widely available and relatively affordable compared to the costly and labor-intensive shellfish purple dye, which was also used as a pigment in antiquity. To me, this speaks to the agency and creativity of the people who were commissioned to paint this striking portrait. Now let's take a look at two of the excavated panels that are preserved in the Kelsey collection. These painted panels were discovered at Karanis in 1926. Although perhaps not as visually compelling as the portrait of the woman, they are extremely important objects for research, and that we know their archaeological provenience down to the rooms in which they were discovered. Our study of the Karanis panels is part of our larger NEH-funded technical study of Roman Egyptian color. Because of the scale of the project, our goal was to look at 200 objects total. We engaged the assistance of U of M researchers, student researchers, to gather technical data. Laurel Fricker on the left and Harrison Biggs on the right used MSI and XRF analysis to investigate pigment use on artifacts. X-ray fluorescence spectroscopy, or XRF, is a technique that uses X-rays, to identify chemical elements present on the surface of an object. And we were able to add this important piece of pigment research equipment to our lab, thanks to NEH. Excuse me, getting over a bit of a cold. The first panel from Karanis is a rather unassuming fragment of a portrait, but it's significant because of where it was discovered. The fragment comes from an underground room, room W, in what could have been either a house or a public storage area for grain at Karanis. Neither of these spaces served a funerary function, which makes the discovery of a portrait like this in such a location rather intriguing. Excuse me. It challenges what we think we know about how mummy portraits were used. The fragment is also painted in an unusual way. The artist dotted indigo blue into the sitter's hair for reasons that are not entirely clear. You can see that it appears red in the infrared reflected false color image in the center, these small pink dots here, and faintly in the indigo subtraction image on the right, here along the edges of the hair. Now, more research is needed to answer these questions. Namely, why was this used this way? Was it done to adjust the tone of the hair? Excuse me. Was the brush that was used contaminated, or a tool that was used contaminated? But in the meantime, I welcome your suggestions if you have any ideas. Our technical research revealed something even more intriguing in this final panel painting. So sorry. The painting was also discovered at Karanis and was originally cataloged as a fragmentary portrait of a woman. At first glance, the painting sort of looks like it could depict hair. We know precisely where this panel was found as well, and what was found with it. As you can see, the accompanying finds provide compelling evidence that this panel was used in a house. The pigments we found were interesting as well, and including the only confirmed use of the yellow pigment orpiment on any of the objects in our study. But something else also appeared while we were imaging the panel. When we looked at the panel using our modified DSLR camera under infrared light, we saw this. Now, can anyone take a guess at what this could be? You can put your ideas into the chat if you like. Well, I can tell you that's definitely not a portrait of a person. After taking a close look at the panel with Terry Wilfong, our curator of Greco-Roman Egypt at Kelsey, we've determined that this is actually some kind of bird, and it could in fact be an eagle. If you look really closely, you might be able to make out a wreath clutched in the bird's talons. This potent symbol has led us to think that this panel could possibly have some connection to military culture. There are plenty of visual comparisons to draw from. For example, on this scutum from Deir Europos, this eagle is clutching a wreath, but it even has a medallion like the Kelsey's eagle panel does. But more than that, we have site-specific papyrological and archaeological evidence of a military presence at Karanis during the 1st and 2nd centuries CE, when Roman soldiers and military veterans settled in the village after serving in the army. While we don't know exactly what kind of object this eagle panel comes from, it's easy, or at least tempting, to imagine this painting having a presence in the home of a retired Roman officer. We have much more to learn about the portraits and panel paintings that are preserved here at the Kelsey, and we look forward to reporting more results in the future. I would like to thank, first and foremost, the NEH for their support, as well as the project's many collaborators, especially Christina Bisulca, for supporting our research on these paintings. And thank you all for your attention.
Great, thank you so much for that, Carrie. So that was a really fascinating presentation. And just a reminder to save your questions till the end. You can put them in the chat at any time, but we're going to address them at the end. And I will let our Vice President, Marisa Speitman, introduce our second speaker of the evening.
Good evening, everyone. It's my pleasure to introduce Ellen Hanspach-Bernal, conservator at the Detroit Institute of Arts, and her presentation, Deconstructing an Ancient Egyptian Mummy Portrait at the Detroit Institute of Arts. Ellen is a 2006 graduate of the Art Conservation Program at the Academy of Fine Arts, Dresden. From 2006 to 2009, she was the Andrew W. Mellon Fellow in Painting Conservation at the Menil Collection in Houston, Texas. She has worked for the Classic Stiftung Weimar and for the Conservation Center for the Museums of the City of Erfurt, Thuringia in Germany. In 2015, she returned to the United States to work as Conservator of Paintings at the Detroit Institute of Arts. Welcome, Ellen.
Thank you, Marisa. Thank you, Julian, for the general introduction, and thank you, Carrie, for your talk. I just noticed that my biography was so boring compared to Carrie's, and I was thinking that, so I'm a paintings conservator. I'm not someone that's specialized in antiquity or an objects conservator. So what I think is interesting that I think what I really love about many paintings, especially those in our collection, is to look at their many, many lives. And I was realizing while listening to Caroline that I think I never worked on an object that was never meant to have several lives. Like this was meant to be buried and stay there. So let's start. So among the Egyptian antiquities in the Detroit Institute of Arts, DIA, is a mummy portrait of the Roman period. Painted on a single piece of wood, it features the head and draped bust of an unknown woman. Although displayed like a two-dimensional portrait on the museum walls, in its ancient Egyptian context, it would have been affixed over the head of a mummified body. The mummy portrait's archaeological provenience and the exact location of the portrait's excavation site, if it was ever recorded, cannot be traced based on the documentary information we have. Stylistic clues have been used to locate the portrait, and because of the distinct stepped contour of the panel, it is believed to have originated from Antinopolis. you missed this page. Okay. Okay, records at the DIA indicate only that the object was given to the museum in 1925 by Julius Haas, who had purchased it from the art dealer Dekran Kelekian, a successful dealer of Islamic art and Egyptian antiquities. A circa 1927 photograph shows visitor on a tour of the Egyptian gallery in the newly inaugurated Detroit Institute of Arts on Woodward Avenue. The mummy portrait is partly visible on the far right, framed and installed on a wall like any other painting on display in the collection. As part of the Getty's Appear initiative, and Appears here stands for Ancient Panel Paintings Examination, Analysis and Research. The DIA Conservation Department unframed the panel for examination to contribute technical information to the project's database. However, because of the extensive restorations that became apparent, much was suddenly questionable, and further investigation seemed prudent to better anchor the work. At the same time, our study continued to focus on the post-ancient alterations to the portrait to garner more information about the path it took from the time it left Egypt to its arrival at the DIA. The research revealed not only further information on the making and intended use of the DIA's funerary portrait, but also its place within the colonial legacy of Egyptian archaeology. The panel was examined by close visual observation and using mostly non-destructive instrumentation and imaging techniques. And I have listed them here, and many were also used by Carrie. In rare cases, samples were removed and analyzed. And one sample we took was from the wood. The wood from which the panel was cut was identified as tamarisk. Within the known body of wooden mummy portrait supports, the choice of this native wood is rare and its selection unusual. Tamarisk wood is not of particularly high quality, and panels made from this material needed to be of a thicker cut to maintain stability. However, panels believed to have originated from Antionopolis generally show a wide range of different wood species. Beechwood, native sycamore fig, or cedar, for example, have all been identified. Compared to the wispy thin panels made from imported European lindenwood, speculated to have been flexible enough to sort of move with the contours of the mummified body, most of the Antionopolis boards are of substantial thickness of up to 2 centimeters. In this context, the Detroit panel may not be such an outlier and may fit well within local artistic tradition and preferences. The wood grain of the panel is irregular and numerous knots and other small defects are present. On the back of the panel, a white fill was brushed over a knot, as you can see here in this purple or blue oval. Resin residue on top of the white suggests that the fill was applied prior to attachment of the board to the mummy. Similar marks are present along the bottom edge, but are now mostly covered by later fibrous fills. In addition, light-colored fills that were inserted from the front can be observed in the wood. These fills suggest that holes left from removed knots or of other origin were addressed prior to painting, likely by the carpenter who prepared the panel. Examination of the panel also suggests that the board was sawn into its distinct stepped shape only after painting was completed. No ground or paint layers overlap onto the sides of the narrow top section, which you can see in the top detail here. Paint from the front still extends over the sides of the wider bottom half, which indicates that these are the initial edges of the board. And again, that's the bottom detail. Changes to the board's dimensions after painting suggest that the final shape of these panels is closely tied to the process of including the portrait within the mummy wrappings. On the lower reserve, layers of fabric fragments from the mummy wrapping have survived. These textile pieces are of various weave weights and densities and are saturated with a dark resinous material. Today, these shroud fragments remain the most tangible connection of the portrait to its original function and larger form. To prepare the panel for painting, a thick, thin, dark brown ground was applied throughout the surface. The colorants identified to this date are listed also here on the screen, are consistent with those typically found in ancient Egyptian art, including Roman period mummy portraits. One of them is the plant-based meadow lake, and its spatial distribution can be inferred through the strong orange-pink fluorescence emitted under ultraviolet illumination, something Carrie also talked about. In our panel, the red matter was combined with indigo to create the purple hues in the tunic. Meadow lake in pink purple garments, as well as the mixtures with indigo, is consistent with finds of other funerary portraits. For example, the Harvard portrait of a woman that's also believed to be from Antionopolis, and you will see that portrait in a little bit. Another pigment characteristic of the ancient Egyptian palette is the yellowish white mineral jarosite. In this portrait, jarosite was identified in the bright highlights of the woman's white garment, where it was mixed with lead white and Egyptian blue. The use of Egyptian blue in the white of the garments, especially of the scarf, but also sparsely in the flesh tones, was inferred through visible induced near-infrared luminescence. Again, the same process that the Kelsey team also used. But you can also see the really sparse and scattered Egyptian blue particles under the microscope. Otherwise, they are so sparse that they're really difficult to detect. The colorants are bound in wax, most likely beeswax. Different application marks are visible on the encaustic surface. The artist employed a stiff, narrow tool that left concave marks in areas where fine, complex shading was required, for example, in the face. In sections of uniform colors, such as the background and the garments, they utilized brushes of various widths. The use of multiple application techniques within one painting has been well noted in other mummy portraits as well. One of the most interesting and unusual features of the Detroit portrait is the high relief collar-like gold necklace with a coin pendant. And I have here an example of an actual necklace. So the pendant is likely indicating a mounted Roman coin. The necklace is made of stucco made of calcium carbonate bound in an animal glue, from which a moldable compound was made. To prepare the surface that would receive the gold leaf, the artist applied a layer of red bole. The gilding is a gold alloy that contains minor amounts of silver and copper. In a final step, the necklace was outlined in a red iron oxide paint. The distinct surface of the necklace may provide insight into how this element was made. The surface texture resembles the imprinted weave of a textile, possibly to mimic woven gold chains found in similar necklaces. This could indicate that a textile was pressed into the surface during construction. The necklace also has designs that appear to be made with a straight tool impressed into the surface on both sides of the collar to create a V-shaped pattern, presumably to depict the twist of the gold chains. The precise placement and sizing of the necklace makes working with a custom-made model, as well as placing the stucco before it was set, most likely. High relief ornaments like this are overall rare in Roman Egyptian funerary portraits. Nevertheless, gold necklaces in low relief or other forms of gilt stucco are not as uncommon in examples from Antionopolis, and I have listed some of the examples here. A nearly identical coin necklace is also found on a funerary portrait at the Walters Art Museum. And we just finished like a very close study between these two works, which I'm not gonna dive in this evening, but the results of that will hopefully be published soon. Examination of the DIA portrait also revealed large areas of restoration that took place after the piece's excavation. Large losses and associated repairs are located along the left edge and the upper right corner. Further additions of overpaint, glues, and coatings are present as well. Photographs of the portrait taken at the time of its acquisition show it with the major restorations already in place. We can therefore conclude that the repairs were completed before 1925. The quality of the repairs, executed in wax paint that carefully matched the original technique, suggests that they were done by a restorer who had specialized in paintings with the ability to closely match colors and brushstrokes. The restorer aimed to render the portrait pristine with very little visible signs of damage or loss. While the repairs to the DIA mummy portrait indicate a skilled restorer, it is possible that in the reconstruction of the loss around the proper right shoulder, that person may have misinterpreted the evidence that remained. So if we just remove that repair, we see this. So by filling this loss with purple paint, the shawl now displays two colors, white over the proper left shoulder and purple over the proper right. Bichrome shawls are not found in depictions of contemporary garments in other mummy portraits. However, in many of them, the shawl is draped over just one shoulder. And as for example, in this portrait here, the Louvre mummy. Tunics worn in Roman Egypt were often decorated with two parallel strips that extended from shoulder to hem. It is possible that the woman's white tunic was decorated with two wide purple strips, similar perhaps to how the garment was represented in the Harvard portrait that you see here, but with the one over her proper left shoulder partly covered by the white shawl. Faced with a large loss that did not provide enough information, the restorer could have misinterpreted the fragmented stripe over the other end of the shawl as the other end of the shawl. The interpretive retouching therefore provides a resolution to the garment that may be misleading, especially because the repair is not easily distinguishable on first look. A misrepresented garment may obscure the archaeological interpretation of the depicted person's function or status. It has not been possible to determine by who and when the restoration was completed. Many early 20th century galleries employed restorer, which could suggest that the Kilikian gallery arranged for the treatment of the portrait. A review of other mummy portraits sold through that gallery, however, revealed that they did not all receive the same level of restoration. One example that's now at the Carlos Museum was found to have been assembled from at least 3 different portraits, while others show little evidence of restoration, such as the already mentioned Walter's portrait. With the extensive repairs present in our panel, especially so close to the neck, one even wonders if the necklace could be a modern edition, crafted after the Walters one to make the work more appealing on the market. Which, if that was the case, and at this point, the necklace is still considered authentic to the painting, and there is more evidence suggesting it is than the other way around. But if that was the case, that could further indicate Kilikian, because the Walters portrait was also sold through the Kilikian gallery. Considering that we do not know how Kilikian acquired the DIA portrait, it is possible that the restoration was completed prior to its arrival at his gallery, or equally, it's possible that Haas, the owner before the DIA, had the work restored. Nevertheless, the treatment history of the Detroit portrait is closely connected to the reception and popularity of these ancient portraits in the late 19th and earliest 20th century. Archaeologists, dealers, and collectors often prioritize the painted panel over the full shrouded body, and considered them lucrative artworks that could easily be displayed like Western paintings. This likely a reason why so few extant mummy portraits are still associated with their human remains. And to conclude, material evidence gained directly from the DIA mummy portrait has allowed us to bridge some of the gaps resulting from the missing physical and archival information. Even though we still do not know where and when the mummy portrait with its attached portrait, where and when the mummy with its attached portrait was excavated, the technical information roots the work firmly in antiquity. Further, its specific techniques and materials, as well as stylistic features, strongly suggest its production and possible deposition in Roman Egypt's Antinopolis. Through material evidence, we were also able to trace the panel's transformation from part of a mummy into a portrait painting displayed in a fine arts museum. The wood panel was separated from the human remains, the whereabouts of which are unknown. The absence of an archaeological context contributes further to the erasure of the deceased person's identity, as well as a loss of knowledge about the specific cultural and religious practices that surrounded this object. Therefore, this technical investigation also clarified the panel's evolving functions and its modern identity as a dissociated fragment. Despite the many remaining gaps, the palpable human traces of its unknown makers and the material connection to an individual's funerary rite add important context to the research, care, and presentation of these complex ancient objects today. And I thank you very much for listening.
Much, Ellen. Very fascinating. Thank you so much. Now, Heidi Hilliker, our secretary, is going to read your questions for our speakers today and facilitate the discussion that will be the remainder of the event this evening.
Great. Hello, everyone. So if you have any questions, feel free to add them to our Q&A. I feel like you were all very enthralled in our talks, so you maybe haven't jotted down your questions yet, but just take a moment. And I do have a couple to get us going. This is for both of our speakers this evening. Thank you so much for sharing your research with us. You both discussed different technologies for using light to understand the composition of pigments. And for those of us that are not experts in this field, I'm curious to know how do you know what pigments will turn up as certain colors underneath? For example, you were saying that there's the reflective spectrum. So what colors can we expect to see in the reflective spectrum, and how do you know that? Does that make sense?
I can start. It's really hard to sum it up in a slide, but basically pigments and dyes are materials like anything else, and they are able to absorb light and reflect light in ways that are unique to their chemistry. And so we can predict how they're going to behave under different wavelengths of light. The other thing that helps us is that there's a limited palette. So if we see a red or pink area of color on an object, and we know that it's probably going to be an iron-based red or an organic red, and we know how those two types of pigments behave under different light sources. So we can kind of target our techniques based on what we're expecting to find. It gets more complicated when you have things like mixtures, because then you have sometimes overlapping behaviors, and whether it's a mixture or not, or just layers of different colors, it can get, it's not always as simple as what, as what I'm saying, but it's basically a kind of a materials science approach to pigments and dyes. And the nice thing about technical imaging is it produces something visual that you can kind of explore and line up and compare. That's my attempt at an answer to that one.
Thank you. Ellen, do you have anything to add?
No, I think you did a good job. I mean, in a way, we're using light when we are able to, like, when we're seeing persons, right? The reason why we see colors and perceive colors is because of the way light is absorbed or reflected in the visible spectrum. So with these techniques, we are just like narrowing the spectrum. And I mean, maybe to add what Caroline said is that we can look at known materials, like we can have references. But I also think what became clear is that one technique by itself is not really useful. Like, I think it's often a really multi-pronged approach. There's not this one magical technique that will like spit out all the answers. So it's really a combination of looking at the various results of what you see with your own eyes in daylight through the microscope and with other data. and only then, like in this combination and with comparison to other materials and to the time when we expect something was made.
Great, thank you both so much. That was very informative. Thank you for answering my question. We have a few questions in the Q&A. First, we have an anonymous attendee that just wanted to clap enthusiastically. So I wanted to pass that on to you all. The next question is from Margaret. Where are the likely elements of color found in these portraits? Egypt, elsewhere?
Yeah, that's the question I am always asking myself when we identify a pigment. The really wonderful thing about Roman Egypt is that there's this whole foundation of artistic practice coming from Egypt proper. And then you introduce, over the course of many centuries through the Ptolemies up until the annexation of Egypt into the empire, the introduction of new techniques for making funerary art and all kinds of new materials coming from outside Egypt. And a number of the ones we see, for example, rose madder, weren't in use in Egypt before the Ptolemies. And other lead-based pigments, for example, like red lead, you really only start seeing them during the Roman period in Egyptian art. So I think a lot of us assume that if we're seeing these, or green earth as well, if we're seeing these new pigments, they must be coming from somewhere else because suddenly they're available. But really, there were local sources of these pigments like green earth, for example. So, without certain kinds of research, for example, there are isotopic studies that have been done that can precisely pinpoint the source location of a specific pigment. Like the red lead on the red shroud mummy of Heraclides at the Getty is an example I use a lot. They pinned that one to Rio Tinto, Spain. So they know where that came from when it was used in Egypt. Other ones, we'd have to do a lot of follow-up analysis to find out, to answer that question. So it's hard to say.
I mean, this is not an answer about the colors, but the panels, right? The wood is also interesting around these portraits. And that's like this surprising, this unexpected initially discovery that so many were painted on woods that could be clearly traced back to, or not traced back, but that could be traced to Europe, like the linden panels. And it looks like the majority of them were painted on imported wood. And right now it seems like portraits like the one at the Detroit Institute of Arts that's painted on local wood is the exception. And Caroline, about the Egyptian blue, because I think, so initially there was always, it's considered one of the, I think the earliest or one of the earliest synthetic sort of human-made pigments. And I think the knowledge of manufacturing this pigment disappeared for centuries. But I think newer research is so difficult to identify because it has similar characteristics to others. But I think there is kind of evidence that it may have sort of had a life until the Renaissance in Italy, but it's not that common, right? Like that's like a really like an example of a technology that gets lost,
it
right?
didn't last. Yeah, it certainly, it lasted through the Roman period, and it was in use in the Near East and throughout the Mediterranean by that point. They were manufacturing it in Italy. So it was available, but it's a bit of a mystery to me why it dropped off when it did. But I think it's also a question of are people looking for it or not? And it's so easy to find if you have the imaging technology. And there's also questions about, I think a lot of people assume that Egyptian blue was expensive. and because it's blue and it's a color you have to manufacture. And there are archaeologists who've been studying the economics of color and have been looking for information about how inflation impacted the cost of Egyptian blue during the Roman period, that sort of thing. There's a publication about that in the first volume from the Appear conference back in 2018 that's really interesting by Gabrielle Thibaudot. That doesn't really speak to the use of Egyptian blue, but it does speak to availability, and I think that definitely plays a role in terms of what was used, what was selected over time.
Yeah, I mean, it's so interesting to think of the Egyptian blue as pricey because it feels like such a European perspective, where then if you look at like starting with like Romanesque or like medieval painting where the blue is the most one of the most expensive pigments, and it's only reserved for really, really the most precious like representations. So at that time, it seemed that only azurite and lapis lazuli, which needed to be imported, were available, and it took a long, long time to develop a technology that would create a stable blue pigment. Like in the late sort of Renaissance, early Baroque, there small shows up, it's not permanent, there's frustrations then later with pressure. Like, it's so interesting that there's this idea of blue as being so complicated and precious. And then like we have it in our portrait where it's mixed with white. It's not even used as a colorant in that sense. It's just
right. It's a tinting agent.
Function.
Yeah.
Yeah.
And it was used that way in wall paintings in Italy as well. And I think it was they knew how to make it. And they figured out, the Egyptians figured out how to make it 3300 BCE. I think that's the earliest known example. So what happened to it? I don't know. I don't know, but these are questions I ask myself a lot.
That's great. Yeah, and Egyptian blue, it is a copper-based color, correct? So is that something that you're seeing in the imaging? Is it something where you're seeing that metal showing up, or in any of the testing?
I think they figured out that what's making it luminescent is the particular complex with the copper. What's interesting is Egyptian green, which is chemically almost identical to Egyptian blue, does not luminesce at the same wavelength. So there's something very particular going on in that molecule that is, showing up at that wavelength, 960 nanometers in the infrared. But copper is the source of the blue color, and in that complex, yes.
Interesting. Oh, go ahead, Ellen. I was going to read another question.
Just saying, by the way, because our I don't know if you remember, Caroline, initially we couldn't detect the Egyptian blue. And we needed a lot of tweaking, like to really make it adjustable to the quantity we had. And I also did not see it under the microscope because I also didn't expect it. And then when I was really specifically looking, because I was suspicious about the luminescence image, I didn't want it to be like something off. That's when we really could confirm it. And you could also think it like a natural azurite or so, just this greenish blue. So
yeah, you do have to have your imaging kit set up a particular way and to have your lens filter targeting that particular wavelength. And it took us some troubleshooting to get ours working right too.
Well, thank you. That was a great question that led into several discussions. We have another question from Teresa. Was the necklace and possibly the earrings of the first woman's painting also gilded?
Also gilded?
Also gilded.
Yes. It is definitely gold leaf. Yes. Mm-hmm. Yeah.
Teresa also wanted to let Ellen know that she is Austrian and you share the same mother tongue. Were there different pigments used in pre-Roman times in Egypt than during the Roman period? This is also still Teresa's question.
Yeah. Well, I think the pre-Roman or the Pharaonic Egyptian pigment palette is more like a foundation to what was used during the Roman period. So a lot of the same ones that were used, continuously through the Pharaonic era continued to be used into the Roman period. But then you add red lead, green earth, madder lake or rose madder, more lead white as well to that palette. It's more like it expanded. I can't think of any that dropped off during the Roman period. But yeah, that's a really interesting question. It's not something what my research is focused on how it's grown.
Caroline, what about the wax, using wax? Is that something that Roman?
That might be a Roman. See, it's getting out of my zone. We're getting into binders, which is where Christina, the scientist we work with, knows a lot more about this. I think the earlier periods, the binder of toys tended to be gums and that sort of thing. But that doesn't mean that there aren't examples of wax being used. I just can't think of any. Oh.
Yeah, also egg, right?
Oh yeah, an egg.
Yeah, I think there's all this like evidence of like learning how to like hatch, have the hens hatch.
Right.
And then with because I was just thinking like there are pigments like, for example, the lead white, you could not make a paint with it with gums because it would just be turned transparent. So some materials also needed sort of a different vehicle. Was madder then planted in the Roman Egyptian territory, or was that
I don't know if they farmed it or if it was naturally, if it grew in the wild, but it grew all over the Mediterranean, North Africa, up into the other side of the sea. As from what I recall, I think it was in Spain as well. Indigo was also, a lot of people think of indigo being imported from the East, but there's evidence that it was available in Africa as well. So, but whether it was something they were growing themselves or not, I don't know.
Great, thank you both so much. We have gotten to all the questions, and I think that we will transition into the end of the presentations. I will let Julian close us out. And thank you to all the attendees that put questions into the Q&A.
First, I just want to say thank you so much to everyone who, contributed in various ways to this this event. It's been so enjoyable. I hope you've all enjoyed it as well. Just to close us out, I wanted to invite everyone to connect with us. You can visit our website at rcdetroit.com and shoot us an email at rcdetroit@outlook.com, especially if you would like to be included on our mailing list to hear about future events. You can send us an email requesting that. We also are on social media at rcdetroit on Instagram and on Facebook. A video recording of this talk will be uploaded to our website in case you want to look at it later or share it with other people. We also request that if you have a minute, you take our post-event survey so we can figure out what events you would like to see from us in the future and what we can do better in our programming. So you can either scan the QR code with your smartphone or type in this URL over here in your search bar. sorry, we can't share links in this kind of Zoom, unfortunately, I don't think. So, QR code. But yeah, it'd be great if you could take that survey for us. It should estimate, I only think it would take 1 minute and 30 seconds. So yeah, thank you though so much for being, generous with your time with us this evening. And again, to all of the RC officers and our wonderful speakers who contributed to this event. Thank you so much. All right, bye.